Okay, so today I want to talk to you about the mechanisms for regulating water intake. Now, there's two main parts to this, and that includes the plasma volume and the extracellular fluid osmolality. So when you are dehydrated, you'll have an increased extracellular fluid osmolality due to decreased water, which is detected by the osmoreceptors in the hypothalamus. They then go on to stimulate the hypothalamic thirst centre. There will also be a decreased saliva, which will cause a dry mouth, which will also play a role in stimulating the hypothalamic thirst centre. Now, before we go on, I also want to talk about plasma volume. So when you're dehydrated, there will also be a decreased plasma volume. This decreased plasma volume will cause a decrease in blood pressure, which will be detected by the granular cells in the kidney. The granular cells detecting the decreased blood pressure will then stimulate the renin-angiotensin-aldosterone mechanism, which involves a cascade of reactions which ultimately results in an increase of angiotensin II. This increase in angiotensin II then also works on the hypothalamic thirst centre. So by these few mechanisms working on the hypothalamic thirst centre, this creates a sensation of thirst and stimulates the person to take a drink. Once the person has taken a drink, this then works back on the hypothalamic thirst centre, and the water moistens the mouth, the throat, stretches the stomach and intestine. This water is absorbed from the gastrointestinal tract, which then causes a decreased extracellular fluid osmolality and an increased plasma volume. To have a basic understanding of this mechanism, I think the diagram on the whiteboard there in front of you, it gives you a pretty good understanding of just the main players in the regulation of water. So just to briefly go over it again, the main players are the extracellular fluid osmolality and the plasma volume. The osmoreceptors in the hypothalamus will detect the extracellular fluid osmolality increase and stimulate the thirst centre, and the granular cells in the kidney will detect the decrease in plasma volume, which will stimulate the renin-angiotensin-aldosterone mechanism, which will then stimulate the hypothalamic thirst centre. The hypothalamic thirst centre then goes on to stimulate the person to take a drink, which then ultimately results in water being absorbed from the gastrointestinal tract and a decrease in extracellular fluid osmolality and an increase in plasma volume back to normal homeostatic levels. I'm going to make another video a bit later that goes into the renin-angiotensin-aldosterone mechanism, but for now I think this provides a pretty good basis of just some understanding of the regulation of water intake. Thank you.